So first of all, let's talk about what is the meaning of dynamic routing. I mean, dynamic routing as simple as that. When you talk about the term called as dynamic routing, dynamic routing is basically, configuring IP based routing protocols, IP based routing protocol, uh, which will help, just take it a bit down here, which will help you decide, which will help you, advertise the directly connected networks, okay, to the neighboring routers or layer 3 devices. So basically, dynamic routing protocols are run always on any layer 3 device, which could be a router, could be multi-layer switch, could be a firewall, right? So you run dynamic routing protocols. Now, configuring dynamic routing, basically you are going to run a routing protocol which will help to advertise the directly connected networks to the neighboring routers or any layer 3 device. Okay. One more feature is those, I'll say RP. So RP is like, routing protocol in this case. So those routing protocols will also help to converge and reconverge for the routes learned dynamically. So I'll tell you what is the meaning. Okay. So wait for it, and there are a lot of features. I mean, we divide the concept of dynamic routing with respect to two part. So let me take out the slate and explain you. So when you talk about dynamic routing, when you discuss about the concept of protocols, we divide the protocols in two half. Okay. So first half is called as, the first part is called as, IGP. Okay. And the second half is called as EGP. IGP stands for Interior Gateway Protocol. EGP stands for Exterior Gateway Protocol. So what does IGP means is, as the name says, Interior Gateway Protocol. I mean, whatever protocols you will have under IGP, they will work within same autonomous system. The term is AS. Here AS stands for autonomous system, right? Autonomous system. So this protocol, whichever is part of IGP, so I think IGP is a container. So this IGP is going to carry or hold some protocols. So protocols that is part of IGP are basically, RIP. We have EIGRP. We have EIGRP. We have OSPF, and we have ISIS. So those protocols are all called as dynamic routing protocols, and they are part of your IGP. In EGP, I mean, the protocol that is part of EGP will generally, it is made to work, it will work between the AS. Where AS stands for autonomous system. Now, what is autonomous system? I'll talk about it. Hold on. But EGP, under EGP classification, under exterior gateway protocol classification, you have only one protocol, which is called as BGP. And this protocol, it is generally used by the ISPs. Okay, it can be used on the customer side as well, but it is a must protocol for the ISPs. It's a protocol which will help you to route your internet, addresses. We'll discuss about BGP overview and we are in your course. So what we'll do is, we'll talk about, what is the concept of autonomous system now. So think autonomous system, the word AS, autonomous system is kind of a domain. Okay, it's a domain. Domain, think like, it's a kind of a boundary for you. Okay. And when I say within the same autonomous system, it means, I've got multiple sites, I've got multiple branch offices. These are my edge routers of my branch offices. they're connected with the help of the ISP somehow. Okay, and say this is the company which is say Cisco, and Cisco has got multiple branch office in different locations of the city, or might be between cities. All right, might be it is a branch office 1, this is branch office 2, this is branch office 3, right? Different branches of the same company. And whatever protocols you decide to run within the 3 branch office, right? Within the 3 branch office, so that protocol will be called as IGP, right? So you would run some flavor of IGP, either RIP, EIGRP from this list, right? You will run some flavor of IGP within the autonomous system. Okay, now if you think like what is the meaning of between the autonomous system, is very simple. So might be we have got another domain over here. So we're talking about IGP. So IGP is within the AS and EGP is between the different AS. So you have got, let us say a domain of, as I've told you, right? This is a domain of Cisco, and some of the device on that Cisco domain wants to connect, to another domain. Let us say this is Airtel, or some of whatever different domain you consider, right? So in this case, if you want to route, if you want to advertise the networks of one AS to another AS, okay, then those propagation networks would be generally done by using the protocol called as BGP. Although BGP can run within the AS also, but general purpose of BGP is to route or advertise the networks between the autonomous system. Okay, so very simple. So IGPs run within the autonomous system. IGPs would run inside the autonomous system, and BGP would run generally between the autonomous system. Okay, now what is the primary job of a routing protocol, which could be either any IGP or any BGP? The primary job is to advertise the networks, right? So for example, if I have here, 2 routers, if I have R1 that is connected somehow to R2, and behind R1, let us say I have got a network which is say 1.0.0.0/8. I'm just taking as an example. Don't think public address, private address, whatever. So think I've got a network sitting behind R1 in the LAN, likewise behind R2 in the LAN, and they're connected via, let us say, a 12 dot network over here. Now, what you do is, this is port number, E00. This is port number E01. This is a port number E00 again. So you go and configure the IPs respectively, right, on those interfaces from these respective networks. And the moment you configure the IPs from the respective networks on those routers, they would learn something called as routing table. So they will have routing table, and they will have those routes populated as a connected routes. Similarly, R2 will have a routing table. Those routes will be appearing as a directly connected routes. So you'll have the routes appearing here as 1.0.0/8. Okay, and this will be like 12.0.0.0/8. Likewise, you have here 2.0.0.0/8, and you'll be having here 12.0.0.0/8, right? So the moment you configure the IPs respectively from the respective networks on this port, you'll have the networks populated as a connected routes on the routing table. Now, you know that from day one, when you discuss about IP routing and when you discuss about static routing, right? So, as of now, the remote networks of those remote branches are not known to the local routers. So R1 does not know regarding 2 dot network, R2 does not know regarding 1 dot network, right? In order to make them know about those remote networks to each other, we do normally go with static routing. And there are, I've told you, disadvantages with static routing, because if I have to remove or add new networks, that things becomes manual to me. But what happens here is I would go and run one dynamic routing protocol on both the routers. Generally make sure that should be the same routing protocol between both the routers. If I choose, let us say, if I think that these 2 routers are part of the same autonomous system, think like 2 branches of same company. This is like branch 1 and branch 2 of same company. I would choose a routing protocol, which is same again. Think like, let us say I choose RIP as a routing protocol over here. So it should be RIP on the other side as well. Okay, so one side RIP and one side EIGRP, by default, they will not talk to each other. So protocol, has to be the same. Okay, so there are cases where you can have, different routing protocols inside the autonomous system, but we will discuss those advanced cases when you go for advanced studies. But as of now, just to begin with, understand that we must have the same routing protocol between the sites of same company. Okay, so what is the purpose of RIP? We just go to in both the routers, okay, and we will say to both the routers that, hey, I'm going to run RIP inside both the routers operating system, and you would actually inform RIP regarding the directly connected networks of each router. So tell RIP that Mr. RIP, you're running on R1, and this router R1 has got these two connected networks. So the RIP protocol sitting at R1 would come to know that it has got this 1.series network and this 12.series network. Likewise, you will go and inform RIP protocol that, hey, this particular router has got this two network, which is 2.series network and 12.series network. Now the job of RIP is to do what? The purpose of RIP is to advertise those routes to each other. So RIP of R1 will advertise those connected routes configured to it to R2, and R2's RIP would be advertising the connected routes configured to R1. Okay, so in this way, you understand that once the RIP protocol starts advertising those connected networks that you have configured, so with the help of this protocol RIP, there will be a keyword R entry would be made on the local router, and with the help of this protocol RIP, R1 would know about this 2.series network. Okay, because RIP would go and advertise actually both the networks, whatever you have informed to R1, but R1 already knew 12.series with him, so it will for him the unknown network is 2. And he will accept that using RIP. Okay, likewise at R2 also it will say that, okay, through RIP I'm going to keep or learn 1.00/8 network. Right, so if tomorrow you add some new networks, let us say on this router you add another LAN, right, another network, or another two networks you add, which is something X and Y. On this routers you add some networks, say it is P and Q. So your job is to advertise those connected networks into RIP. So tell RIP now, hey, what, X is there and Y is there as connected route newly added, and you tell him that, hey, what, P and Q has been configured on this as a connected route. Now they will actually share those updates to each other, right? So as an example, I'm saying with the help of RIP, automatically R1 would learn regarding P and Q. Okay, like as an example, I'm saying it's not PQ is a network address, but just as an example to make you understand. And here this router would learn regarding X and Y. Right, does it make sense? Right? So the whole idea is if I run a dynamic routing protocol, make sure that very simple. So to dynamic routing protocol, you will go and advertise that routers directly connected networks. Right, so if this router has 4 networks and you want to advertise all the 4 networks, so the job of that particular protocol will be to inform those 4 networks to the neighboring router, and the neighboring router, when he receives it, make sure that he is running the same protocol to understand the protocol update and receive the protocol update and populate its tables. All right, so as discussed, to talk about dynamic routing, we have got 2 protocols that we'll discuss. We'll discuss 3 protocols with respect to IGP. So we'll discuss regarding RIP. We'll see the features of RIP, how it works. We'll see the features of EIGRP, how it works, and then we'll focus with OSPF. Okay, we'll see the basic operations of those and how they behave. Likewise, with respect to EGP, we have a very big protocol which is called as BGP, and I'll give you an overview of what is BGP and how it works, so that at the very basic level the importance of those protocols. But to be frankly speaking, if you work with any IGP, this is the protocol that would be heavily implemented. Most of the companies, most of the places, you will find OSPF is the protocol of choice with respect to IGP. And when you talk about any advanced design with respect to ISPs and internet trafficking, if you want to work with that, then it is going to be BGP. Okay, now RIP is just a protocol which was experimental protocol. It was really not appreciated into the industries because it has got a lot of disadvantages with respect to advantages. So you have to understand RIP as a very beginner level. You have to understand how this protocol RIP behaves and what are the basic features RIP carries and why it is bad as compared to other protocol, right? Why this protocol was not taken into granted by the organizations. Right, let's talk about that. And EIGRP, yeah, it is a very great protocol. It is Cisco has made this protocol, so it is called as a Cisco proprietary protocol. So EIGRP is made by Cisco. Okay, the team of Cisco. It is called a Cisco proprietary, routing protocol. And the case with EIGRP is it can be used only with Cisco routers, right? Although there are certain new, documents have released where it is getting claimed that EIGRP can be used between Cisco and non-Cisco devices, but to be honest, I mean, EIGRP so far, I mean, in the implementation cases, you will see it is only with Cisco gears, right? So it's like, if you have everything as Cisco, then going with the EIGRP is the best choice for IGP. If you have multi-vendor, like some devices are Cisco, some devices are of different companies, then go with OSPF because OSPF is open standard. Okay.